right, ready to dive deep. Today, it's all about 3D printing.
3D printing, huh?
Yeah. You know, printing in 3 dimensions. Sounds kind of gimmicky, but
Oh, it's way more than a gimmick, trust me.
I bet. It's amazing how 3D printing's come a long way.
Right. It used to be something only huge companies could even think about. Just for prototypes, too. Pricey stuff.
And now, you see it popping up everywhere.
Seriously, everywhere. Factories are using it, but get this, even some people have 3D printers in their homes. Wild, right?
Totally. And the stuff they're making is mind-blowing. Prosthetics, parts for rockets.
I even saw a story about someone 3D printing a whole house. A house!
No way. That's insane. But before we get too ahead of ourselves, back to basics for a second.
Absolutely. Gotta start somewhere.
So how does 3D printing actually work?
Basically, it's all about building things up layer by layer. Like, imagine a super precise hot glue gun that can follow digital blueprints. Any shape you dream up, it can make it.
So instead of like carving something out of wood or whatever, you're building it up.
You got it. Slice by slice, like a high-tech loaf of bread.
Uh-huh. Okay, I like that. Makes sense.
Good, good. And all 3D printers follow the same basic process. First, you've got to have a digital 3D model, right? The blueprint.
Okay.
Then special software slices that model into super thin layers, like crazy thin.
And then,
The printer takes those slices and, well, it translates them into instructions it understands.
so the printer's like following a recipe, but instead of flour and sugar.
It's using plastics, metals, sometimes even. Ready for this?
Oh.
Wood.
Wood.
Yeah. I saw this video online. Someone printed a prosthetic hand using wood filament. Looked and felt so natural, it was amazing. The most common way to print with plastic is fused deposition modeling, or FDM.
FDM.
That, like that hot glue gun analogy. You've got a spool of filament, which is like plastic thread, feeding into a heated nozzle.
Melts the plastic and bam, builds it layer by layer.
Right. Some filaments even have metal powder mixed in, and then they use this process called sintering to make it solid.
Sintering, like baking it.
Kind of. It heats the printed part to just below the metal's melting point.
So the metal particles fuse together.
Exactly. And you end up with a solid metal object.
So not melting the metal like a welding torch. More like.
Baking a metal cake.
Perfect. Now, FDM is great and all, but I know there are other types of 3D printing out there, right?
Oh yeah, definitely. Each one has its own quirks and strengths.
What about that one that uses lasers and liquid resin?
Ah, you mean vat photopolymerization?
Yeah, that's it. Sounds pretty intense.
It's cool. This was actually the very first patented 3D printing method, believe it or not.
Wow, really?
So imagine a vat of liquid polymer. But this stuff is special. It hardens when you shine light on it.
Interesting.
So a laser or UV light traces each layer's shape onto the liquid surface, curing it. Then a platform lowers that hardened layer down, more liquid flows over it, and they do it all over again.
Building it up from the bottom.
Right, using light instead of chiseling away.
Cool. So that's got to be super precise, right?
Oh yeah. Perfect for small, detailed stuff. Things like custom dental crowns, jewelry, tiny parts for electronics. And since you're only curing what you need, barely any waste.
Makes sense. But what's the catch?
The downside is you're stuck using those special photosensitive resins.
Okay, so maybe not for everything.
Right.
Now, what about bigger, stronger stuff, like car parts or airplane parts? I can't imagine they're using resin for that.
Nope. You need different methods for that kind of thing. One option is material jetting.
Material jetting.
Okay. It's basically like an inkjet printer, but on steroids.
Steroids. Okay, now I'm really curious.
Think of those inkjet printers you use at home, but instead of ink,
They're shooting out tiny drops of.
liquid photopolymer, or sometimes wax. Then a UV light cures each layer, just like with vat photopolymerization.
So similar idea, but different materials.
Exactly. And here's the kicker. You can have multiple print heads, each with different stuff.
So you could print in multiple colors.
You got it. Or even use different materials within the same object.
Whoa, like a model car. The body's plastic, the tires are rubbery, and the windows are clear.
All printed at once. Pretty cool, huh?
Wild.
And that's not all. There's another type of material jetting called nanoparticle jetting. They use heat instead of UV light to fuse together tiny, tiny particles of metal or ceramic.
So even more possibilities with materials.
Yeah. It's still pretty new, but it has huge potential, especially for making super strong, complex metal parts.
Okay, let me see if I've got this right. So far, we've got FDM, vat photopolymerization, and material jetting. That's 3 down. How many more to go?
A few more. And each one opens up a whole new world of possibilities, trust me.
All right, I'm ready. What's next?
All right, next up, we've got binder jetting. This one's different. No filaments, no liquids. We're talking powder.
Powder, huh? Okay, walk me through it.
So picture a bed of powder. Could be metal, ceramic, even sand, believe it or not.
Sand, wow.
Yeah, and the printer has this nozzle that sprays a binding agent onto the powder, basically like glue.
So instead of melting the powder, you're gluing it together.
Exactly. Anything that doesn't get glued can be reused, which is great. Less waste.
Makes sense. And what's this method good for?
It's popular for stuff like metal toys, consumer products, that kind of thing. It's fast and can handle making a lot of stuff.
Okay, I'm following. But what about, like, really heavy-duty stuff?
You mean like for airplanes or spaceships?
Yeah, I can't imagine glue's gonna cut it for a rocket, you know?
Good point. You're right. For that, you need something a bit more powerful. That's where direct energy deposition comes in. Or DED for short.
DED, okay. Sounds intense.
It is. Get this. A powerful laser melts a stream of metal powder AS. It's being deposited onto the platform. Fusion, layer by layer.
Wow. So it's like a super precise welding torch.
That's a good way to put it.
And they're making what with that?
Aerospace components, power plant parts, even repairing oil rigs, stuff that needs to be crazy strong and withstand extreme conditions.
Wow. So not just for making new things, fixing old ones too. That's amazing.
It is. All right, ready for a change of pace?
Sure, bring it on.
Let's talk about sheet lamination.
Sheet lamination. That rings a bell, but
Yeah.
refresh my memory.
Think of it like high-tech paper craft.
Paper craft. Okay.
No liquids, no powders, no filaments here. This one uses thin sheets of material. Could be paper, plastic, composites, even metal foils.
Okay, I'm picturing it.
They cut these sheets into the exact shape of each layer and then bond them together.
Like a 3D puzzle. That's kind of fun, actually.
It is. It's great for making quick, affordable models and prototypes.
Not for heavy-duty stuff, though, I'm guessing.
Right. Not the strongest method, but great for visuals.
Got it. Okay, so we've covered a lot of different ways to 3D print.
We have. But there's one more I want to talk about. It's the one ACS specializes in, actually. Remember we talked about powder bed fusion?
Powder bed fusion, or
Yeah.
PBF. Yeah, I remember.
Yeah.
That uses powder too, right?
It does. Specifically, ACS focuses on selective laser melting, or SLM.
SLM, right. But how's that different from binder jetting? They both use powder.
Good question. They do, but SLM uses a super high-powered laser to melt and fuse the powder particles together layer by layer.
Okay, so more precise than just gluing the powder.
Way more precise, and it makes parts that are just as strong and dense as those made with, traditional metalworking.
Wow, serious stuff. Like what are they making with this?
Aerospace components, medical implants, even parts for nuclear reactors.
Nuclear reactors. That's insane.
It is pretty wild. And SLM isn't just about strength. It lets you make objects with crazy complex shapes, internal channels, things you just couldn't make any other way.
So they're using it for those medical implants that like mimic bone structure and stuff.
Exactly. It's incredible what they can do.
It really is. We've gone from printing little plastic toys to parts for nuclear reactors. The possibilities seem endless.
They really are, and it's not just about the tech itself, it's about what it's doing for all these different industries.
Speaking of which, let's dive into some 3D metal printing applications. That's where this tech is really making waves.
Oh yeah, for sure. And there's no better place to start than aerospace and aviation, always pushing the limits, that industry.
High-tech stuff, rockets, airplanes, gotta love it.
Right. And 3D printing is a huge part of making them lighter, stronger, more efficient. Not just prototypes anymore. We're talking real parts, flying in real aircraft.
Like what? Give me some examples.
Turbine blades, fuel injectors, even structural parts for satellites. The cool thing is, 3D printing lets them design parts with all these complex internal geometries. You couldn't make them any other way.
So lighter, but still super strong. Because of the design.
Exactly. And often they can print one complex part instead of putting a bunch of pieces together, fewer welds, fewer joints, less chance of something breaking.
Especially important when you're talking about things flying around, right?
Big time. Less risk. And these lightweight, complex parts, they're huge for fuel efficiency and how well the aircraft performs overall.
So 3D printing is literally taking aerospace to new heights.
Nice. Now, what about cars? Is it having a similar impact on the automotive industry? Oh, absolutely. It's changing everything.
Oh.
How they design cars, how they make them, even how they repair them. Rapid prototyping is huge in that industry. Speed is everything.
Yeah, I can see how being able to print a part overnight and test it the next day would be a game changer.
Totally. But it's not just prototypes. They're printing actual car parts now. Radiators, heat exchangers, even complex stuff for high-performance engines.
Engine parts, wow. I bet in something like Formula One racing, that speed is everything.
You got it. 3D printing lets them tweak and improve their designs all season long, gives them an edge on the track.
So it's not just about doing things faster, it's about doing them better. I like it. Now, let's switch gears a bit. What about medicine? How is 3D printing impacting that field?
This is where it gets really personal. We're talking about tech that's literally shaping people's lives. Imagine creating medical devices and implants that are custom made for each patient's body.
Wow. So prosthetics that fit perfectly move naturally.
Exactly. 3D printing gives you a level of precision and customization you just couldn't get before. And it's not just prosthetics. They're doing custom surgical guides, implants for reconstructive surgery, even scaffolds that can help grow new tissues.
Scaffolds? Hold on. Are we talking about printing body parts here?
That's the ultimate goal. Imagine printing a custom organ for a transplant. No more waiting for donors, no risk of rejection.
Whoa, printing organs. That's next level stuff. Sounds like science fiction.
It does, but it's getting closer all the time. Bioprinting is still early, but the potential is huge. It could totally change medicine.
Okay, so maybe someday we'll be printing replacement organs at home. Wild. What other crazy possibilities are out there?
Well, think about construction. What if we could print buildings right on site, layer by layer?
3D printed houses, like building with giant Legos.
Yeah.
But fancier, of course.
Exactly. And not just houses, bridges, tunnels, even whole cities. We could make customized, energy-efficient structures that fit perfectly in their environment.
Mind-blowing. It's like a whole new era of construction is about to begin. What about space? Could 3D printing help us explore space?
Totally. Think about printing habitats, tools, even spare parts on the moon or Mars, using stuff they find there.
That would make space travel so much easier.
For sure. It's already happening. NASA and other space agencies are experimenting with 3D printing in space, getting ready for future missions.
Incredible. It seems like 3D printing can do just about anything.
It really is changing the world in so many ways. And it's not just about the technology itself. It's about how it's impacting all these different industries.
Right. Which brings us to ACS Material. They're the ones behind this deep dive. And they're not just watching this all happen, are they?
Nope, they're right in the thick of it, shaping the future of 3D metal printing.
So they're not just talking the talk, they're walking the walk.
Exactly. They offer both 3D metal printers and a printing service for those who don't need to own a whole machine.
Smart. So they're making it easier for more people to get involved with 3D metal printing.
Exactly. Their main line of printers is the XDM series, made specifically for selective laser melting. You know, that super precise method we talked about.
SLM, their specialty. What makes these XDM printers so special?
Well, they come in all sorts of sizes, from ones that fit on your desk to huge ones that can print parts several feet long.
So something for everyone, basically.
Right.
What about materials?
They've got you covered there too.
Yeah.
Their XDM printers can handle a whole bunch of different metals.
Like what?
Tool steel, stainless steel, titanium alloys, even aluminum alloys and cobalt chromium alloys. The list goes on.
Wow, they really can work with just about anything, so they can cater to a whole bunch of industries, right? Aerospace, automotive, medical, energy.
You name it. And their printers are designed to be easy to use. They have this intuitive software package that makes it simple to manage designs, customize settings, and fine-tune your prints.
So you don't have to be a rocket scientist to figure it out.
Nope. And for those who don't want to buy their own printer, they have that printing service I mentioned.
Right, so if I have a design, I can just send it to them and they'll print it for me.
Exactly. They handle all sorts of part sizes and materials, so it's perfect for businesses that need to 3D print metal every now and then, but don't need a dedicated machine.
That's awesome. Really cool to see how ACS Material is helping make this cutting-edge tech more accessible to everyone.
It is, and as 3D printing keeps evolving, I can't wait to see what ACS Material comes up with next. They're really pushing the boundaries.
Me too. It's been amazing diving into the world of 3D printing today, from the basics to all the crazy ways it's being used, and even getting a glimpse of what ACS Material is doing.
Yeah, it's clear that 3D printing is here to stay. It's not some futuristic fantasy anymore. It's really changing our world.
Absolutely. And it makes you think, what's next? What does the future of 3D printing look like? So we've seen how 3D printing is already shaking things up, but what about the future? Where do we go from here?
Well, get ready, because things are about to get even wilder. One of the coolest things happening is that 3D printers are getting cheaper and easier to find.
You mean it's not just for those big companies with all the fancy labs anymore? Regular people can actually get one.
Exactly. What used to be super expensive, something only a few people could mess around with, it's becoming more and more common. Small businesses, schools, even people at home can get their hands on a 3D printer.
That's pretty amazing. I can already see kids designing and printing their own toys at home. Or people making custom tools or gadgets, anything they can dream up.
Right. It's like having your own mini factory in your garage. And as more people start using them, we're going to see some crazy creative stuff happening. You could download a design for anything, a tool, a piece of furniture, a musical instrument, you name it, and just print it out at home.
That's wild. But what about the materials? Are we going to be stuck printing in plastic forever? Or will we be able to print other stuff, like metal?
That's another area where things are really taking off. Researchers are coming up with all sorts of new materials you can use with 3D printing: metals, ceramics, special composites, even stuff called biomaterials.
Biomaterials. Okay, I'm intrigued. What's that?
It's like stuff that can work with the human body. Imagine being able to print custom implants or prosthetics that are a perfect match for the patient, or even get this printing entire organs for transplants someday.
Hold on, printing organs. Now that's straight out of a sci-fi movie.
It is. It's called bioprinting, and it's still pretty new, but the potential is huge. It could totally change how we do medicine.
Okay, so we might be printing out replacement organs at home someday.
Yeah.
That's a lot to take in. What other crazy stuff is coming down the pipeline?
Well, let's talk about construction. What if we could print entire buildings on site, layer by layer?
3D printed houses. I love it.
It's not as far-fetched as it sounds, and we could use sustainable materials, so much less waste than traditional construction. And it's not just houses, we could print bridges, tunnels, maybe even entire cities.
So instead of building a house brick by brick or board by board,
You just print it out. And you could make these crazy, customized, energy-efficient structures. Imagine that.
it's like we're on the verge of a whole new way of building things. What about space? Does 3D printing have a role to play in space exploration?
Big time. Imagine printing habitats, tools, even spare parts right there on the moon or Mars, using stuff they find there instead of hauling everything all the way from Earth.
That would make space travel so much more efficient and way less expensive, I bet.
Exactly. And it's not just an idea anymore. NASA and other space agencies are already experimenting with 3D printing in space, getting ready for those future missions.
This is blowing my mind. It really seems like there's no limit to what 3D printing could do.
That's what's so cool about it. It makes you think differently about what's possible. It's pushing us to create a future that's better, bolder, and more sustainable.
I'm going to said it better myself. Okay, so we've come to the end of our deep dive today. We started with the basics of 3D printing, explored how it's being used in all these amazing ways, and even got a glimpse into what ACS material is doing to push the boundaries even further. It's been quite a journey. But before we sign off, I want to leave you with one last question to think about. What role will 3D printing play in your future? Will you be watching from the sidelines as this technology changes the world, or will you jump in and use it to create something amazing, to innovate, to make your own mark? It's up to you. Thanks for joining us today on our deep dive into the world of 3D printing. Until next time, keep exploring, keep learning, and keep creating.